Limit of a function. Here is the notation. We say the limit of f of x as x approaches a equals L. When we say or write this, we mean we can make f of x as close to L as desired by choosing x sufficiently close to a and x is not equal to a. As x gets closer and closer to a, f of x gets closer and closer to L and becomes almost equal to L. Please pause the video so that you can write all of this down. Example 1. Find the limit of x plus 2 as x approaches 3. If x is 2.9, which is close to 3, f of x, which is x plus 2, is 2.9 plus 2, which is 4.9. If x is 2.99, f of x is 4.99. If x is 2.999, f of x is 4.999. This table of values shows that the limit of x plus 2 as x approaches 3 from the left is equal to 5, which means as x, that's these numbers, gets closer and closer to 3 from the left, all of these numbers are on the left side of 3, x plus 2 gets closer and closer and closer to 5. Also, if x is 3.1, f of x, which is in this example x plus 2, 3.1 plus 2 is 5.1. If x is 3.01, f of x is 5.01. If x is 3.001, f of x is 5.001. This table illustrates that the limit of x plus 2 as x approaches 3 from the right is equal to 5. The numbers in the x column are getting closer and closer and closer to 3. These are all on the right side of 3. The f of x values are getting closer and closer and closer to 5. We're writing the limit of x plus 2 as x approaches 3 is equal to 5. The closer x is to 3, the closer x plus 2 is to 5. Example 2. If g of x equals x squared minus x minus 6 over x minus 3, find the limit of g of x as x approaches 3. And here's how we do it. This is equal to the limit of x squared minus x minus 6 over x minus 3 as x approaches 3, which equals the limit of x plus 2 times x minus 3 over x minus 3 as x approaches 3, because this trinomial can be written in factored form. So So this equals the limit as x approaches 3 of x plus 2 which is equal to 5 because this last line here is actually example 1. Here's a theorem. The limit of f of x as x approaches a is equal to L if and only if the limit of f of x as x approaches a from the left is equal to L and the limit of f of x as x approaches a from the right is equal to L. Note, if the limit of f of x as x approaches a from the left is not equal to the limit of f of x as x approaches a from the right, then the limit of f of x as x approaches a does not exist.